What's up, chemists? Today we're going to talk about rounding with significant figures. This will come up every time you want to do math in this class. Every time you want to do math, you're going to have to take your answer, and your answer might have a decimal that runs out basically to infinity, and you got to be able to round that number off. And usually we're going to tell you exactly how many numbers you're going to round your answer to. In math class, oftentimes they say round a certain number of digits past the decimal. They'll maybe say round 1 past the decimal or round 2 past the decimal. But in chemistry, we say let's round our answer based on the number of significant figures. This is why we learned about what significant figures are in the past video lessons, is because once we identify if a digit is significant or not, then we can decide, is the whole number important, or can we round it off after a certain amount of significant figures. So first of all, let's talk about the rules for rounding. Here's an example. Let's take 28.787. If I ask you how many significant figures this number has, you would say that it has 5. All of them are non-zero numbers, 28787, and so there are 5 significant figures. But I said, let's round this answer off, or let's round this number off to 3 significant figures. So what you do is you start counting from the left. 1 significant figure, 2 significant figure, 3 significant figure. And I'm going to underline those first 3 numbers. And then I'm going to draw a vertical line here, because this is the number that I'm going to round. The number just left of the line is the number that I'm going to round, and the number to the right of the line is going to be the determining factor. Is this number left of the line going to round up, or is it going to stay the same? Now the rule is this. If the number that follows the significant figure you're looking to round is a 5 or higher, then the number rounds up. And you drop off all the rest of the numbers if it's at the end of a decimal. But if the number is 4 or lower, then the number to the left of the line stays the same. And once again, you drop off the numbers at the end of the decimal. Now, since my number 28.787 applies to the top rule, if the deciding number is 5 or higher, then the number rounds up. So 28.787 rounds up to 28.8. And then I drop off the last 2 digits. Now, I don't put zeros in their place. And this is important. You don't put zeros at the end of the decimal because those are significant figures. Remember, a significant 0 comes at the end of a number when a decimal point is present. So putting in 2 zeros for these last 2 numbers, the 8 and the 7, would result in, once again, 5 significant figures. But I only want a number that has 3 significant figures. And so I round after the 3rd sig fig and drop off the rest of the numbers. Now, in some cases, you might add zeros if they are placeholder zeros, and I'll show you an example of that on the next page. So I've drawn in 3 more examples, and we're going to round each one of these to 3 significant figures. Pay close attention to each one of these scenarios, because guaranteed each one will come up in a future problem set, maybe a quiz, or even a test. And these are all going to be slightly different when it comes to rounding. They're all done a little bit differently. So let's take a look at the first one, shall we? Now I want to round this number to 3 significant figures. One of my favorite things to do is to draw lines under the first 3 significant figures and then add a vertical line. It kind of shows which number is going to be rounded, potentially, and which number is the determining factor of that rounding. And so I'm going to draw that line in right now. And it's a 4 on the left and a 4 on the right. Now this number is really big, like really, really big, but I'm still going to round it off to 3 significant figures. I'll show you one of the most common mistakes I see with a question like this. And so if I follow my rules, the 2 and the 5 and the 4 stay. And then the students decide that the 4 on the right side of the line means that this 4 stays the same. And then they just leave the answer like that. I have 25,443 meters. I say round that number to 3 significant figure, and they say, oh, it's just 254 meters. That's definitely not what you should do. You can't just make something that was 25,400 meters into a number that's 254 meters. You've lost a significant portion of that measurement. So when I say round it to 3 significant figures, I don't mean just round it to 3 total figures. I'm saying 3 significant figures. In the last problem, we dropped off the remaining numbers because they were at the end of a decimal or at the tailing end of a decimal, and you just drop them off because adding zeros in their place would result in adding significant figures. But notice in this number, there is no decimal point. So if we add zeros in at the end of the number, they do not count as significant. And that's important because we want to keep the 2, the 5, and the 4 in the same place value lane. You learned about place value lanes in math class probably a long time ago in middle school. This 2 is in the 10,000s place, the 5 is in the thousands place, the 4 is in the hundreds place value, then the 4 and the 3 are in the tens and one place value respectively. And when you round to three significant figures, you can't just round it off to 3 digits and call it good, because the 2, the 5, and the 4 have to stay in their lane. And so instead, we're going to add in placeholder zeros at the end of this number. And these are not significant zeros because there's no decimal. But now you have a number that is 3 significant figures, but still represents the basic idea of the original number. It still is relatively close in value. Now it's just rounded off, showing only 3 significant digits. Let's take a look at the second example. Once again, we've got a number that's pretty extreme, but this time it's pretty small. It's extremely little. The first example had a number that was pretty big, and this one has a number that's pretty little. Once again, we've got a decimal. We're looking at a decimal here. Now, if I ask you to round 3 significant figures, students sometimes make this mistake. They say, oh, well, the first 0 and the second 0, I'm going to include the first 2 numbers. So it just says round to the 3 significant figures, or round to 3 digits. But these first 2 zeros are not significant. Because remember, zeros only count if they're significant when they're at the end of a number and a decimal point is present. So these first numbers are not at the end, they're at the beginning. There are, in fact, no significant zeros in this number. The first 2 are not significant. So when I start count significant figures, I begin at the 5, and then the 2 and the 1, and those are my first 3 significant figures. The first 2 zeros are not, but the 5, the 2, and the 1 are. Now that I've identified what numbers are actually going to be rounded, well, the 1 is the one that's going to be rounded, and the 9 is the determining factor. So since 9 is above 5, then this rounds up to 5, 2, 2. And of course I add in these first 2 zeros because they're not significant, and those once again are placeholder zeros, and placeholder zeros are not significant. So in a number that's really, really small, like this, the zeros at the beginning don't count as significant, so don't use them to determine your 3 or 4 or 5 significant figures, whatever the directions say. Only begin counting your significant figures at the first significant figure. 5 is the first, 2, and followed by a 1. Now I've got a number that has 3 significant figures and represents the original value rounded off. Now, like we said on the last slide, we're just going to drop the 9 and the 7 off, and we're not going to add zeros in their place because any added zeros are significant zeros. And so in this case, after the decimal, just drop off the numbers. The most common mistake I see with a question like this is students round this off to 3 significant figures. They say, oh, 0.05. Now the 5 doesn't round up because it's followed by a 2, which means it stays the same, and then they just say, well, that's it. But that can't be it because these first 2 zeros don't count as significant digits, so they cannot be part of the 3 significant figures. This is a common mistake, and I'm showing it to you to help you so that you don't make the same mistake, but inevitably mistakes happen, and that's okay. But we learn from our mistakes, because that's what learning and that's what science is all about. This last example is also one that seems to trip up people. Once again, we're going to round this number to 3 significant figures, and I've got no zeros in this problem, so this is going to be easy at least to identify the 3 significant figures, the 4, the 7, and the 9. So let's draw in my first 3 significant figures and underline them and draw the vertical line so I can decide what number needs to get rounded and what's the determining factor. Now since this 9 is the one that's going to get rounded and is followed by a number that's 5 or higher, then that's going to get rounded up. But 9 rounds up, where does 9 go? 9 rounds up to 10. Well, if that's the case, then this becomes a 0, but then that also then changes the value of this number. If 9 rounds up to 10, then the 7 becomes an 8, and the 4 remains the same value it was originally. So in this situation, you actually change 2 numbers in the final answer. Of course, I'm going to put the decimal point in there so that everybody knows that it's 47.98 rounds up to 48.0. This is the only case where you round more than one number. And that's if the number that gets rounded is a 9 and rounds up. Typically, we only change one number. Let's take a look at our first examples. This was 254, and it happened to be followed by a 4, so it rounded down. So I don't actually change that number. But this next example was 0.0522. Now, it was 0.0521 followed by a 9. It rounded up. The 1 rounded up, but that's the only number that ever gets rounded or ever changes. When you round, you typically only change one number. And so this is the only case where you have two numbers change from the original value. Of course, we don't add any zeros on at the end of this number because, again, any zeros at the end of a decimal are significant and we just drop those digits off. So when I finish writing, it's 48.0 kiloliters. Now this is the most likely application of the rounding significant figures that you're going to come across, and you'll do this no less than 100 times between now and the end of the school year. Every time we do a calculation, we always round our answer at the end, because typically the answer that spits out of the calculator is going to be a lot of significant figures, and we only want to round off to a certain number of significant figures. Typically it's going to be 3 significant figures or 4, but watch the directions because it'll tell you exactly how many significant figures your answer should be. So let's take, for example, 48.9 times 27.3. So I do the math just like I normally would, punch it in my calculator, and I get 1,334.97. Now I want to round this answer to 3 significant figures because the directions say round to 3 sig figs. And now that I've done the math, now I just carry out what I just learned on the last couple slides. I highlight my first 3 significant figures, decide which one's going to be rounded and which one is the determining factor, and then I round accordingly. Now this falls into the same category as that first example that I showed you on the last slide. The 1, the 3, and the 3 stay in their same place value lanes. Everything stays in its same column. And since there's a 4 in this 1's place value, but I don't want it to be significant, I add it in as a 0, and then I drop off all the rest of the digits. Also, don't put in a decimal point at all, because as soon as you put in a decimal point in your final answer, it makes this 0 significant. Remember the quirky situation which I talked about on a previous video lesson? You can have a 0 in the 1's place that's not significant, but as soon as you put a decimal after it, it becomes significant. So don't put a decimal in. I just want 3 significant figures. And so 1,334 rounded to 3 sig figs is 1,330. And then I put a box around that because it's my final and correct answer. And so make sure that you round after each calculation based on what the directions say in the problem. Typically it's going to be 3 significant figures. Sometimes it might be more, sometimes it might be less. Anyway, that takes care of this video lesson on rounding significant figures. Thanks for watching.